So if you want to grab a ready utensil and your notebook, we're going to just walk through these together. So the first thing that we've got are two matrices here, matrix A and matrix B. And we're going to calculate two different products. So here's matrix A on the left, matrix B is on the right. And if you see in the directions here, I want to calculate AB and BA. Now I've mentioned in class a few times how multiplying by matrices is not commutative, which means if I switch the order of the two things I'm multiplying, we're not going to get the same answer. And so I just want to kind of demonstrate that to you right here. And it'll be good practice with just your basic matrix multiplication. So we're going to start by multiplying A times B. So we're going to take 2 times -1, -5, -6 times matrix B, 4, 6, -1, and -5. We're going to multiply these two matrices together. And so remember, you take the rows of the first matrix times the columns of the second matrix. And you multiply the like terms, or the corresponding terms. Corresponding means like the first term in each grouping goes together and the second term in each grouping goes together. So I'm going to multiply 2 times 4 to get 8. And then -1 times -1 is +1. The first element we get is 9. So we'll write that here in our solution matrix. We got a 9. And then we're going to move on to the, still using that first row, but now we're going to multiply it by the second column. So it's like you take that row and you distribute it to each column. So I'm taking 2 times 6 to get 12. -1 times -5 is +5. Add those up and we get 17. 17 is our second element. Now there are no more columns to distribute that to, so we're going to drop down to the second row. And we're going to do that same process of like distributing this row to each column in the second matrix. And we multiply corresponding terms. So the first term in the row with the first term in the column. And -5 times 4 is -20. And then the second term is a -6, and the second term in the column is a -1. Multiply those and you get +6. Add those up and you get -14. And finally, we're going to take that second row again and distribute it to the second column. -5 times -6 is -30. And then -6 times -5 is +30. Add those up and you get a 0 for that last term. All right, so this right here is the product of A times B. Hopefully you all are able to do that on your own, no problem. And so let's now switch the order around. So I'm going to erase these two and all these calculations. I'm going to leave our solution there so we can compare the two. But now we're going to take matrix B times matrix A. So I'm multiplying the B matrix first. 4, 6, -1, -5. In matrix A, 2, -1, -5, -6. So it's the same elements, but now we're going to be multiplying them in a different order. Because now I'm taking the rows from this matrix, whereas the previous time we were taking the columns from the blue matrix. But now we're using the rows. And same thing here with the red matrix, matrix A, we were using its rows before, but now we're multiplying its columns. So it's a different grouping of numbers. So we are going to get different results. Starting off by multiplying 4 times 2 to get 8. We're going to add 6 times -5. It gives us a -30. Add those up to get -22. So now, with this matrix, our first element is -22. So we can already see that this is definitely going to be a different product. It's a different matrix, different solution. First row times the second column. We got 4 times -1. And then 6 times -6 gives you -40. That's our second element. Yep, it's definitely going to be different. And then take the second row times the first column. That's going to be a negative 2 plus 25 to give us 23 for our third element. And finally, we're going to take that second row times the second column, and that's 1 plus 30 equals 31. And so just looking down at the bottom, you can tell that these two matrices are not equal. Even though we multiplied the same two things together, we got two completely different products based on which one came first. All right, hopefully you can see why that's different by using the rows and columns versus the columns and the rows. Any questions on this? Hopefully we're all good to go with multiplying. Pikachu says you're good, so I trust him. All right, here's the second one. So go ahead and jot this down in your notebook. This is a problem from one of your Delta Math assignments from these more basic matrix equations. And so you will see a problem like this on your test next week, where we give you some matrices and you've got to plug them in and solve them for the variable matrix. You know, for matrix X, or maybe matrix A, or matrix C, or whatever letter we use. Doesn't really matter which letter we use. So we've got these two matrices, and we're just going to plug them into that equation on the bottom. So first, matrix A is a negative in front of it, so we're going to write negative, and then we're going to just basically put matrix A right there in that spot. So we have a negative 3, 12, another negative 3, and a negative 8, plus 2 times x. Now, x is our variable, that's our unknown. We don't know what it is, that's what we're solving for. So we're going to want to get x all by itself. That's going to be our focus for solving this equation. Equals 3 times b. Now again, that just means you plug matrix B into that spot. The 3 stays in front. That's going to be what we call a scalar multiple. We're going to essentially distribute that 3 into every element inside the matrix. Make that 5 look a little bit better. Okay, so this is our matrix equation right here. And the first thing you're going to want to do is distribute any scalar quantities that are out in front of the matrix inside the matrix. So we've got two of them here actually. In front of this first matrix A, there's a minus sign, right? And we can think of that as a negative 1. So you're going to go ahead and distribute that negative 1 inside to every element inside that matrix. All right, and so all that's going to do is flip all their signs. That negative 3 becomes a positive 3. This will be a negative 12, a positive 3, and a positive 8. Plus 2 times x. So we can't multiply those yet. We don't know what x is, so we're just kind of chilling for now. And then that last matrix, you have 3 times every element inside here. So you're really distributing this to every number. And so we've got 3 times negative 11 is negative 33. 3 times 0 is 0. 3 times negative 5 is negative 15. And 3 times negative 2 is negative 6. All right, so that took care of all the scalars that were out in front of matrices. And now you just basically think of this as a regular algebraic equation. We want to get the x by itself. That's right there. We want to get it by itself on the left side of the equal sign. There are two other things on the left side. There's this 2 that's being multiplied by the x, and there's this matrix in front that's being added to the x. Now, just like a regular algebraic equation that you're solving, you always want to cancel out or get rid of whatever's being added or subtracted first. So we're going to leave the 2x in place, and we're going to get rid of this matrix on the left. Since this matrix here is essentially a positive, right? There's like an invisible plus sign in front of it, essentially. we're going to subtract it. And so I'm going to subtract this matrix here. And if I subtract it from one side, we have to subtract it from the other side to keep the equation balanced. So I'm going to write that 3, negative 12, positive 3, 8. On the left side, we don't actually have to do this calculation. If we do subtract all these from each other, since it is the same matrix, it's ultimately going to cancel out. It'll turn into a matrix of all zeros. And if you add 0 to something, it doesn't change its value. So we just ignore it. The 2x is still going to be in place. 2 times x equals, let me keep my color scheme going. Do you guys like the colors that I use? I hope so. And we are going to actually subtract these two matrices from each other. You start by just subtracting corresponding elements. So we're going to take a negative 33 minus a 3. So negative 33 minus 3 is negative 36. Or we're just going to do that for every element. I've got 0 minus a negative 12. Be careful, we've got a double negative, so that's going to add to become a positive 12. Then we've got a negative 15 minus 3, which gives us negative 18. And then lastly, we've got a negative 6 minus 8, gives us negative 14. Let me focus on just that. All right, so we're super close to the end at this point. We just want to get that blue x by itself, and it's right now being multiplied by a 2. Now, since the 2 is not a matrix, it's just a number. It's just a scalar multiple. So we actually are allowed to divide by that. Now, you can think of this as, typically you're going to think of it as just dividing by 2, but technically we're multiplying by its reciprocal of 1/2. So we're multiplying this matrix on the right by 1/2, so that those cancel out. But really all we're doing when I distribute in that 1/2, you're just going to divide every element by 2. And then for our final solution, we'll get x equals negative 36 divided by 2 is negative 18. This gives us 6. This is negative 9, and that's negative 7. All right, and so that in blue is what you would type in to Delta Math for your final solution. Any questions? Okay, cool. Well, I've got one more problem for you. You ready? Here we go. Ooh, 3 matrices. This is the one that most students kind of just stopped working on Delta Math. Some of you tried one of these and quit. Others of you just didn't even try the first one yet. It looks kind of scary at first. So I'm going to break this down, make it nice and easy for you. This is a skill, again, that you're going to have to demonstrate on the test next week. So make sure you are legitimately practicing, giving this an effort. All right, so to study for a test, you should really be going through all of our examples first and foremost from class. You know, like one of the best things you can do to get ready for the test is to rewrite each of the example problems that I've gone over in class, write them on like a separate sheet of paper and make that like a new quiz for you or a new mini test. And you can just then try to solve those practice problems, those example problems on your own without looking at your notes, and try working through them. Try to remember the process to solve these. And then after you finish them, you can go back and look at your notes because you've got the whole problem worked out because we did it together in class. And just take a look to see, if you did make an error, where that might have occurred. You can compare it to the correct answers that we already have down in our notebook. All right. So that's a great first step to do to re-practice those questions, to kind of like quiz yourself. And then obviously your homework, that's got to be done first and foremost. That is your practice. No one's going to sit in my class, just watch me do my lesson, and then remember exactly how to solve those problems 2 weeks later on their own. All right. So the homework's got to be done. It's just basic step 1 of preparing for a test, And so go through that. And remember, you can do additional practice problems on Delta Math. You don't have to do just those 3. You can do as many as you want. And so keep practicing them until you feel comfortable. All right, that you feel like, okay, I can do one of these on my own. I know I'm going to get it right. I know the steps. I feel confident and comfortable with it. That's showing me that, hey, you've learned this. You're proficient at these skills. Okay, hopefully you've had enough time to write these down. Let's go ahead, plug in matrices A, B, and C, and then solve this for X. So we're solving for X there on the left. It's going to be multiplied by matrix A, 4, 2, -1, -3, plus matrix B, which is -2, -2, 1, +2. And it equals matrix C, which is 4, 5, 2, and 2. So looking at this, it's the same idea. We want to get the X by itself on the left side. So we have to cancel out this matrix A and matrix B. And matrix A here is being multiplied by the X, whereas matrix B is just being added. And so just like a regular algebraic equation, to solve for the variable, you always want to cancel out or get rid of whatever's being added or subtracted first. And so in this case, that's going to be matrix B. And we see that matrix B is it's got a plus sign in front of it, so it's being added. I'm going to do the opposite operation of subtracting this matrix, because matrix B minus matrix B, if I do this, it's going to cancel out. It's going to equal 0. But to keep the equation balanced, if we subtract that from the left side of the equation, we have to also subtract it from the right side of the equation. Now remember that we don't need to perform this calculation. Don't take the time subtracting those. You're going to get a 0. It's going to be nothing. You just ignore it. Just cross it off. The real calculation is going to come in on the right side. So we're still going to have X times matrix A here, the 4, the 2, the -1, and the -3. But now it equals whatever we get when we subtract the 2 matrices on the right. So again, you're just subtracting corresponding elements, right? The first with the first, but make sure you realize that this is subtraction. So I've got 4 minus a -2. That's going to change the sign to make it plus a +2. So 4 plus 2 is actually 6. Then go to the second elements. That's a 5 minus a -2. That's the same thing as 5 plus 2, which is 7. Then go to the third elements. 2 minus 1 is 1. And the last elements, 2 minus 2 is 0. So here's our new equation that we're going to solve. And here's where we got to do just a little bit of work. Because X is being multiplied by a matrix, I want to cancel that out. And we can't cancel out a matrix by dividing. And so instead, we cancel out by multiplying by the inverse. So I'm going to need to figure out what is the inverse of this matrix right here. And whatever it is, so remember, if this is A, I need to multiply it by A inverse. Now, this is important. The way that I'm writing this down on the board right now is notice which side of that red matrix, matrix A, notice which side I'm multiplying A inverse by. Because X is on the left side already, I can't squeeze in an A inverse right here. There's no room. It's already got a matrix next to it, so we can't do that. So A inverse has to basically be multiplied on the open side, or the side that doesn't have something next to it of that matrix. So in this case, A inverse has to be multiplied on the right side because A already has a matrix on its left side. And whichever side you multiply A inverse by on one part of the equation, so here, since it's being multiplied on the right, on the other side of our equation, we also must multiply A inverse on the right side of this green matrix. And that's because of that first slide that I showed you today when we multiplied A times B and B times A, we got 2 different things. So the order of this does actually matter. You've got to make sure that you're multiplying the correct side. So we need to figure out what is A inverse. I'll make a little side note over here. A inverse equals 1 over the determinant Okay, what is the determinant of A? Remember, this is matrix A in red. So we multiply the first diagonal, which is 4 times negative 3, to give us negative 12, minus the other diagonal, which is negative 2 times, or negative 1 times 2, which is negative 2. Add those up, we get negative 10. So A inverse is 1 over negative 10. And then the matrix that we multiply this by for the inverse, we use those same elements of A, but we kind of scramble them up. So the 4 and the negative 3 switch places. Negative 3 becomes the first element, 4 becomes the last element. The 2 and the negative 1 stay put, but we change their signs. So this is now a negative 2 in the upper left, and we have a positive 1 in the lower right. And that combination right there is our inverse matrix. So remember, the actual calculation is going to come into play right here. It's this green matrix on the right side times A inverse, which we just found on the right. And so we're going to multiply these together. So let me write this out. 6, 7, 1, 0 times our inverse matrix, which is 1 over negative 10 times negative 3, negative 2, 1, and 4. Now, in this situation, it looks kind of weird because there's a fraction in between the two matrices. Luckily, since that negative 1/10 is a scalar, the order that you multiply a scalar is commutative, meaning I can rearrange that scalar term. So I can't switch the order of the matrices, but we absolutely can take this negative 1/10 and just move it out in front of these two matrices. So I'm going to write this as 1 over negative 10. And then we're going to have the two matrices that we're going to multiply. 6, 7, 1, 0. And then the matrix part of our inverse, the negative 3, negative 2, 1, and 4. So this way I can do the matrix multiplication nice and easy without worrying about that fraction in there with that 1/10, because having like 3 over 10 and 4 over 10, that's going to make matrix multiplication pretty tricky. So let's go ahead and multiply the rows times columns, just like we always do. 6 times negative 3, that's a negative 18. 7 times 1 is 7. Add those up, you get negative 11. Then we're going to multiply the first row times the second column. 6 times negative 2 is negative 12. 7 times 4 is 28. Add those up to get positive 16. Then we'll drop down to the second row and multiply it. 1 times negative 3 is negative 3. 0 times 1 is just 0. It's easy, negative 3. Then when we take row 2 times column 2, we get a negative 2 plus 0, which equals negative 2. So those are our 4 elements that we get by multiplying the two matrices. Remember, we still have the fraction, the negative 1/10. But now we've got these 4 elements from the multiplication. So that's this negative 11, positive 16, negative 3, and negative 2. So at this point, it is nice and easy to just distribute in this negative, or 1 over negative 10. You're just going to divide each element by negative 10 and simplify if you can. So you're just going to write all of these as fractions. So you have negative 11 over negative 10. You have 16 over negative 10, negative 3 over negative 10, and negative 2 over negative 10. So that's me just distributing in that 1 over the determinant. And then we're just going to simplify every one of these elements. Negative 11 over negative 10, just cancel out the negatives and make it a positive 11 over positive 10. Next term, you can divide both of those by 2. It gives you a negative 8 over 5. Notice, by the way, how I took the negative that was in the denominator, and you always just want to write that out in front of the fraction. So it can be with the 8, or it can be just in front of the fraction, the way you type it in. Doesn't matter where the negative sign is, but you wouldn't want to necessarily type in 8 over like a minus 5. It might look kind of weird. And then we have positive 3 over positive 10. And then this last one we can also simplify, write positive 1 over positive 5. And this right here is what you would type in to Delta Math. Are there any questions on any of these steps that we took here to solve this matrix equation? Cool. So please give the Delta Math an honest effort tonight and make sure you really try to work through most of them that you can. Tomorrow in class is just going to be a practice day. I've got a worksheet of some matrix problems, and we're going to go through a few more linear programming problems again just to get you refamiliar with that process, to get you ready for your test next week, Monday morning for cohort A, Thursday morning for cohort B. So one last thing I want to show you before I let you go is please make sure you're using Delta Math as a study aid. It is extremely useful. Take a look at this problem right here. So this is a common Delta Math problem for those advanced matrices like the one we just solved together, and it gives you the equation and you plug everything in. And this right here that I'm showing you on the screen, these are the steps that Delta Math shows you. And they're better than the directions I give, all right? They're fantastic because it's actually showing you and explaining what's going on. So it says first step right here. How'd you get to this? Well, you just plugged in the matrices, right? Matrix A goes there, B goes there, C goes there. All right, well, what'd you do in this part? It says multiply by the scalar value. Well, that's perfect. The scalar was this -5 that's out in front. So it just distributed it and it just changed this matrix. So hopefully you can see that, oh, the first matrix and the last matrix stayed the same. What's the only thing that changed? Oh, we multiplied the -5 into every element in that matrix. After that, combine matrices. Okay, so there's an addition sign right here. So it's just adding them up and get this new matrix times X. Awesome. Then what do? Well, we wanted to cancel out this matrix here. And so it says we're multiplying by the inverse on the left. See how that's all in capitalized letters? That's because of that whole principle where the order of multiplying a matrix matters. And since in this scenario, X, the matrix we're solving for, is on the right, that means I have to multiply the inverse matrix on the left. All right, so you have to multiply by it on the left over here. And notice how even Delta Math, it doesn't actually take the time to multiply these together. It just crosses it off because we know it equals the identity matrix, and the identity times X would just equal X. So we can just ignore it. Moving on, we have to find the inverse of the 2x2 matrix using that little shortcut method, right? 1 over the determinant, and then you kind of switch all the terms around. It's doing the exact same thing that I've been teaching you, that I've been showing you. After you multiply the matrices together, see it says multiply the 2x2 matrices together first, leave that scalar out in front. Then the last thing you do is distribute that scalar, that -1/4. You're just dividing each thing by -4 and simplify your fractions. So that Delta Math solution, that's what it tells you. If you get it wrong or if you click on like show example, it walks you through everything. You should use that. You should learn from that, all right? You practice it enough times and you'll get it, honestly. But that's pretty much it for today. We got like 10 seconds left, so work on this and come with questions tomorrow. And have an awesome day. Bye, everybody.
See you later.